Is there someone else who'd like a question, please? To John Hall.
You're talking about the carbon dioxide in the atmosphere rising. Once I have a little bit of knowledge of chemistry, carbon dioxide is 1.5 times heavier than air. So if it's 1.5 times heavier than air, how come it can go up?
Okay, it's the concentration, and there's a hell of a lot of turbulence that drives the system, so it's evenly distributed from the top to the bottom, or fairly well, yeah.
Okay, somebody else with a question for Bob? Chris.
Chris Capel. This is just a basic one. Can we have a copy of your presentation, please?
Yes, look, it's there for everyone to use, and also to please always be a sceptic and criticise where you feel it's appropriate, because that's the only way we all collectively learn. And I'm projecting stuff through my lenses. You may have a different set of lenses. That's going to be available to you. Please use it, and if there are issues that you want to take up a week's time, a month's time, then please contact me.
Thanks. Colleen's just nodded to me when I signalled to her. She said that those people who want it will be able to have a copy of that presentation and the material that's in it. Okay, is there anything else that we've got? I'm just going to go to Peter first and then to Errol.
Peter Witt. One of the maps you had up there was showing the changes in rainfall projected into the future, and it seemed to have a fairly negative sort of band through pretty much here and south of here, going back into the Northern Territory. What's that based on, and could you just give us a bit more detail on that?
Sure, and you can pull that photo or that picture off the web and create your own. The site is the Bureau of Meteorology, long-term weather patterns. So if you go into the bom.gov.au, you'll find access to that material. That is actually rainfall data that has been collected by all of the registered rainfall stations throughout Australia by the Bureau of Meteorology since records began. So that's what that is derived from. It's not something into the future, it's looking back through time, and it's real data.
Thanks, Bob.
The colouring, of course, is the averaging. You might have one particular rain station that has a high recording and the 7 around it lower. That drags that one back, of course, as an average. But yes, that's real data.
Yeah, Errol, Dave would like people to stand up so that he can actually catch you on the film while you ask the question, and so if you don't mind, we'd appreciate...
That's so Jerry can get you later.
Yeah, Bob, Errol Entrigan. Just a question on regards to melting and shifting of...
Just closer, please. Closer.
Yeah, regards ice melts and glacier movement. When it actually melts or moves, or the ice actually drops into the ocean, what's the time frame between when that happens and when it affects, or say Australia? Is it sort of more or less instant, or is it sort of like it takes a long time to flow?
Yeah, once the land mass, or the mass of ice that's on the land starts to melt, you'll see rapid shifts. At this stage, the majority of the ice that is melting is the sea ice that is embedded in the sea. So it is making a change, but one of the changes to the sea level is also the increased temperature of the sea. So as the temperature of the sea increases, the water expands. So you're getting some contribution from the sea ice, which isn't going to be the big driver of the major sea level rises. The big driver is when the land ice starts to melt. And in geological time, a 7 to 9 metre rise has been recorded historically.
My question really was
The actual time frame of when the ice hits the water. Like I'm an irrigator. If I put water in one end of my paddock, it takes
You know when it's going to get
10 hours to flow through. Is it the same with water? Is the height here has got to flow, or is it more or less instantaneous, or is a very long time frame between when the actual water enters the ocean or the ice enters the ocean to when it actually affects the landmass 1,000 kilometres away?
Yeah, it's a little bit like a bucket with a sinker. If you drop one sinker in, it rises this much. If you drop 50 sinkers in, it'll rise by that much, and if you drop 200 in, it'll rise by that much. It's that sort of phenomenon. So you get a local response, but you've got to note that the ocean is driven by large conveyor belts of current, and huge influences in terms of where the tides go, and so you get quite marked differences between where the tides rises occur. And you
Is
will
there a
get
time relationship?
no,
Bob?
there is none that I can give you that gives you a direct answer that it'll be, if it melts today, it'll be in Australia next week. Yeah, I can't give you that.
Okay, thanks, Bob. So there's no... one more, Dave? And can you do the stand-up bit for...
David Phelps. Bob, a question relating to the ice actually dropping in the ocean. Is that going to impact on the sea surface temperature at all, or is it already impacting?
Yeah, obviously as ice melts, it cools the water around it that it's influencing, but probably the bigger impacts that are likely to occur is changes to those conveyor belts that run up and provide actually warm water up in the equatorial, in the Arctic region. The conveyor belt stopped a couple of years ago, so that upflowing of warm water that provides that high level of productivity up there stopped. And so that is probably a far greater concern than the ability of the ice to cool the water around it. Because what you've got from sun is that the white reflects the radiation and the black, if you like, of the water absorbs it. So you get a very short-term period of cooling as the ice itself melts, but it's rapidly warmed to a higher degree, if you like, because it now absorbs the temperature where the ice reflected it.
Thanks, Bob. Now I'm going to wrap up the questions from there, please, and take us to our next speaker. Before I do so, I'm not quite sure how comfortable those seats are, so if you did want to sort of just stretch for half a minute or something so that you can actually listen. I saw a couple of people stand up and move to the back is what prompted me to do that, so if you do need to do a bit of a move, just a half a minute while we change speakers.